Okay, so you take a minute and read the question. If you have to, just pause the video if you haven't already read the question. Now, if you look at this, it's saying that G has to be on US, so here somewhere. Okay, now it doesn't really say where G has to be, but let's just kind of think about this for a minute. If I had put G right here, and then it says HG is drawn, so let's just look at that. Okay, I would hope that you would see we're trying to prove that these two triangles are equal, which is this triangle right here, HUG, this little one on the top, and then HSG, HSG, which is this one on the bottom. These guys don't look like they're equal. So you really kind of want to put G right here in the middle, just like that. Okay, so now listen to what I just said. G would have to be in the middle of U and S, which means UG would have to be equal to SG. Okay, so I'm just going to start to label a couple of things here. So that means G really is the midpoint of US. Okay, G is the midpoint of US, and then this side is equal to this side. Now, the other thing that hopefully you would see is that HG right here is a side in this triangle up on the top and the triangle on the bottom. So remember that when that is a side of both of these triangles that we're trying to prove are equal, we call that reflexive. So I'm going to we tend to put an X there for reflexive. Okay. All right. Now, lastly, if HG, let me get my little pointer going here. If HG comes down and forms right angles right here, and let me just kind of, okay, right angle. I just want you to take a look. We've got side, angle, side, which is what this is asking. And let's try on the other side. We've got the side HG, this angle down here, and this side right here. So these two triangles are equal by side, angle, side. Now, if you read this, it says which additional information is sufficient to prove these triangles are equal by side, angle, side. Okay, so let's go here. Choice one says HG, that would be this line right here, bisects US. In other words, it cuts it in half. Well, yes, this is equal to this, but that's not, like, if this is all they gave us, that's not enough to prove these two triangles are equal, because granted, HG would equal HG by reflexive, and UG would equal SG because of this bisector. But that doesn't tell us anything about the right angles, so this isn't the correct answer choice. Now let's look at this one. HG is an altitude. Well, an altitude, I don't know if you remember or not, but an altitude is a line that forms right angles at the bottom, which this does, right? But an altitude, by definition, only forms these right angles. It doesn't tell us that GS and GU are equal to each other. So that's not our answer choice. Okay, let's get this one. HG bisects UHS. So let's find UHS. UHS. Okay, so let me pick a different color here just so you can see. Here's UHS. We know nothing about that. Okay, so that is not going to help us to prove that these two triangles are equal by side, angle, side. Okay, so it's got to be this last one. Let's talk about it. So HG is the perpendicular bisector. So two words, perpendicular. So let's talk about this. Here's HG. Perpendicular means we form right angles. Check. Okay, so check. We got that. Bisector means we cut things in half, which, if you look right here, UG and GS, right? So perpendicular bisector. And this is just our reflexive. So choice 4, that's your answer. Okay, again, if you haven't read this question, take a minute and read that. So I drew my little sad looking cone there. Okay, now let's look at the first sentence. It says the area of the base of the cone is 9 pi. Well, this is the base of the cone. And isn't that a circle? Okay, so I'm going to take that out of context for a minute. And I know that the formula for the area of a circle is pi r squared. And they're telling me that area is 9 pi. So I'm going to then replace this A area with 9 pi. Okay, so watch. 9 pi equals pi r squared. Now I'm going to try to get the r by itself because that's the thing I don't know. So since pi is getting multiplied by r squared, I'm going to divide by pi and divide by pi. And that cancels this out, and it actually cancels that out also. So 9 is equal to r squared. Now, if I wanted to find r, you have to ask yourself, what's the opposite of squaring? Okay, and the opposite of squaring is square rooting. So that will cancel out that squared, and I know now that r is the square root of 9. Now, you can put that in your calculator, or maybe you know it. The radius is 3. Okay, now you may be asking a really good question. Miss Carter, that's not what they asked for. You are correct, but we're going to need this, honestly, to find that. So let's hang on a sec. All right, so let's go to the second sentence. The volume of the cone is 36 pi. So we need to know the volume formula. Okay, all right, so the volume is 1/3, and you'll get this on your sheet, 1/3 pi r squared h. Okay, all right, we want to know what is the height of the cone. Now they give us the volume right here in the second sentence. They tell us it's 36 pi. So I'm throwing that in right here. Equals 1/3 pi. Oh, look at that r. So see, we did this for a reason, because we needed to know r in this formula, and there it is right there. Okay, all right, so we're going to put 3 in there. We're going to square that. And then we don't know what h is, which is what they're asking us to find right here. So we're good to go here. All right, so let's just do a little bit of math. I'll see what we get here. So that's an equal sign, sorry about that. So we're going to do 1/3 pi, and then 3 squared is 9, h. Okay, so then you can take your calculator, because I'm going to multiply 1/3 times the 9. Don't worry about the pi. 1/3 times 9 in your calculator. Okay, if you haven't done that, take a minute, pause me and do that. And that would be a 3 pi h. Well, let's kind of do what we did over here to get the r squared by itself. I want to get the h by itself. So what I'm going to do is, since I know this is all being multiplied, I'm going to do the opposite, which is dividing by 3 pi and 3 pi. Okay, so that disappears there. Now the pi's are going to cancel out, and you just have to do 36 divided by 3, and that will give you your h. So your h is 12, which is choice 1. All right, so again, make sure that you've read the question. If not, just pause me, read it, and unpause me. Okay, so this question is asking which segment, we're talking about AB, so this is our image, what we're starting with. And so then which one of these remaining 4 would be the image of AB after we dilate it with a scale factor of 2, which means we make it twice as large, centered at -2,1. So this is the part where it's a little annoying, because we love it when it's centered at the origin, because it makes it a little bit easier, but it's not. Okay, so what I'm going to start by doing is I'm going to plot the point -2,1, just so you kind of get the gist. So there is the point that we're dilating this about. Okay. All right. So one of my students taught me, actually, what I think is a pretty decent procedure. I don't know if I call it a trick, but a procedure. So what they said to do was you start with whatever the center of dilation is, and what you're going to do is you're going to do the opposite. So just bear with me a second. So I'm going to add 2 to the x value. And I'm just going to write add 2x. Okay, and what I mean by that is this is an x value, but that says -2. So I'm doing the opposite of -2, which is +2. In other words, add 2. Okay, and I'm going to do the same thing with the y. I'm going to do the opposite. It's -1 or -1, right? So I'm doing the opposite, which is add 1 to the y value. Okay, all right, so what does that give us? So let's do this. So what I'm going to do is I'm going to add 2 to this, so -4 plus 2. And when I do that, -4 plus 2 is -2. And then I'm going to do the same thing. I'm going to add 1 to the y value. So I'm going to add 1 to that 3, which is going to give me 4. Now this is not our answer. It's just like a little procedure that tends to work. All right. So then the next thing we're going to do is we're going to dilate 2, which means enlarge something, right? When we dilate, we make things larger, and we make things larger by a scale factor of 2. So what that means is we're going to multiply this by 2 and this by 2. Okay, so -2 times 2 is -4, and then 4 times 2 is 8. Okay, last thing is now what we're going, now remember, this is all just a procedure that helps us get the answer. It's not like one strict rule, okay? So because we did the opposite of whatever this was here, now we're gonna undo it and put it back, so to speak. So in other words, I'm gonna do exactly what this says. So that says -2. So what I'm gonna do is I'm going to subtract 2 from my x value, and then I'm going to subtract 1 from my y value. Okay, so I'm doing the opposite of what I did here. All right, so here we go. Oops, gotta put my pen on, that would be nice, right? Okay, so now I am subtracting 2 from here, and I'm subtracting 1 from here. Okay, and this will give us our final answer for point A anyway. All right, so I'm going to subtract 2 from -4, so -4 minus 2. You can put that in the calculator or you can do it in your brain. And then subtract 1 from 8, which would give me 7. Okay, so this here is going to be the point that we're looking for. Okay. All right, now from there, we could probably figure out what the answer is going to be, but I want to just do a little bit of extra practice with point B. So I'm going to do the same thing. I'm going to add 2 to x, and I'm going to add 1 to y. And when I add 2 to x, I get 4, right? I'm looking at this point right here. And then when I add 1 to the y value, I get 2. Then we dilate 2, because that's what the problem tells us to do, right? And that means multiply by 2. So if I multiply 4 by 2, I get 8. And if I multiply 2 by 2, I get 4. And now we undo what we did in the first step. So we're going to subtract 2 from the x, and I'm going to subtract 1 from the y. Okay? And remember again that we're doing it from this previous step here. So if I do 8 minus 2, I will get 6. And if I do 4 minus 1, I will get 3. Okay, so now we are essentially, what we're doing is we are looking for these 2 points. And those 2 points will be the endpoints of one of these lines. All right, so let's look for -6, 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it looks like it's going to be EF. Okay, so we got E, and if we look at F, 1, 2, 3, 4, 5, 6, 1, 2, 3. Bingo. So our answer is EF, and that would be, whoops, that would be choice 2. Okie doke. Okay, so I am going to start by, after reading the question, they want to know which transformation would map point A. Now, I'm just going to find the coordinates for point A. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. All right, so the coordinates for point A then are -7, 3. All right, now they want to know which transformation is going to map this point here onto 3, -7. So I am going to plot that one. So that's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So we're going to be putting a dot right there. Okay, so there is your A prime. All right, so what I like to do is I like to kind of write this separately. So A is -7, 3. And A prime they gave us is 3, -7. Because I think when you write them down either next to each other or underneath each other, it's a little bit easier to see what is going on here. So I'm going from here to here. Look at what's happening. Do you see that these numbers are flip-flopping? So this is an X value here, but here it's a Y value. And 3 is a Y value here, and then it's an X value there. So when we switch X and Y around, there's a rule that you should know. And that rule is it's a reflection in the line Y equals X. Okay, so a reflection in the line Y equals X, which is choice 1, will take a point. Now I'm just making up, X comma Y, because everything can, X could be anything and Y could be anything depending on the problem. So like, for example, in this case, X is -7 and then Y is +3. So this XY will go to YX. That's the rule for a reflection in the line Y equals X. You just switch the X and the Y around. So when you see that happening, which we do right here, that's a reflection in the line Y equals X. Okay, that's just a memorizable rule. All right, so this is a fun one. Now, so if we look at this picture, first thing that I'm going to notice is that bottom piece right here is 12, and that refers to this circle. And what that is it's telling you from this point right here all the way over, aka the diameter, is 12. So that would then mean that from the center out, that would be the radius, that would be half of that, right? So that would be 6, which means then up here, that radius would also be 6, which also then means if I went straight up like that, that's also a radius to, hold on, to this hemisphere here also. See, so from here to here is 6, but then from here to here would also be 6. All right, so let me throw that in there as well. Okay, why am I doing that? Well, good question. Okay, so if this piece is 6, right? You were really good at this when we did this the other day in tutoring. If this whole piece right here is 6, okay, now I'm going to just shift this out. Ready? So from here to here is 6, right? What's the distance from here all the way down? What's left over? In other words, what's this distance right here? So if you do 30 minus that 6, you're going to get this piece right here. Okay, so I'm going to go like this. So from here down to the bottom would be 30 minus 6, which is 24. Does that make sense? Okay, all right. Now, why am I doing that? I'm doing that because they're asking me to find the volume of this storage building, which is this whole thing. Remember we talked the other day, it's like if I put a little pinhole in here and I fill this whole thing up with water, that's volume. So the way I'm going to find volume, now you have formulas on your formula sheet, but this is not one shape. It's not just like a sphere or just a cone or just a cylinder. It's actually two shapes. we have a cylinder on the bottom here. That's why I needed that 24. And we have a hemisphere, meaning a half of a sphere. So we're going to use two formulas and we're going to add them up to get that total volume. So I'm going to find, so this is our little game plan, right? I'm going to find the volume of this cylinder. I'm going to find the volume of a full sphere, and then I'm just going to cut it in half. Okay, and so here we go. So the volume of the cylinder, if you look on your formula sheet, is area of the base, which is a circle. So the area of a circle is pi r squared times the height. Okay, and then the volume of the sphere is 4/3 pi r cubed. And we are going to add those two volumes together to get the volume of the entire storage building. Okay, all right, so let's start over here on the left. So volume equals pi. We know the radius is 6. We're going to square that. Now the height, be careful because this is doing the volume of the cylinder, which is this bottom part, and the height is 24. Okay, don't use the 30. We needed the 30 to get the 24. All right, so we're going to put 24 in here. And I'm just going to use my calculator, and that ends up giving me, when I throw it all in, 2714.3360 plus. All right, now let's go over to the other side. Volume equals 4/3 pi, and we know that the radius is 6 cubed. And again, just throw that into your calculator, and I get 452.3893. Then I'm going to add those two up, and my final volume is 3166.7253. Okay, and then they rounded that because this 7 is going to bring up that 6, and so the answer is choice 3. Okay, this question is really on a lot of Regents exams, so let's go over this one. This is a good one. Okay, so it says which regular polygon. Regular means all the sides would be equal. So if we were looking at number 1, a type of triangle where all the sides would be equal would be an equilateral triangle, right? So we would only be talking about an equilateral triangle. Pentagon would be a 5-sided figure where all the sides are equal. Hexagon in choice 3 would be a 6-sided figure where all the sides are equal. Choice 4 would be an 8-sided figure where all the sides are equal. Okay, so they want to know which regular polygon will carry onto itself after a 135-degree rotation about its center. All right, so let me just kind of get to the point here. So there's a little trick, and basically what you do is, if you think about it, when we rotate something, the most we can rotate something is 360 degrees, all the way around like a full circle. So what you do is you start with that 360-degree figure and you divide it by the number of sides of the figure. So in this case, a triangle has 3 sides. And then I do that and I get 120. Okay. So I could rotate a triangle 120 degrees. So here, let me just show you. If I rotate here, A to B, then B to C, then C to A, I have rotated 120 degrees. Okay. But maybe I could go from A to B to C. That would be 240 degrees, right? Or I could go from A to B and all the way back around to C. Okay, so generally, basically what this boils down to is when you divide 3 into 360, 3 because triangle's a 3-sided figure, you get 120. And then what you can potentially do is, I'm going to take 120. You can use your calculator. I'm going to double it. In other words, multiply it by 2. I get 240. And then add another 120, or here, hold on, sorry. Then triple 120, multiply it by 3, and you get 360. Okay, just hold that thought for a second if that's not totally making sense. All right, let's go to choice 2. Pentagon. Again, always 360 divided by the number of sides, which is 5. Pentagon has 5 sides. If you divide that, you get 72. Now, if you double 72, you get 144. If you triple 72, multiply 72 by 3, right? You get 216. And then I could quadruple, because remember, the max I can have is 360. But you'll see in a second, no need for me to go that far. Okay, hold on. It'll make sense, I promise. All right, hexagon. So we're going to do 360 divided by 6, right? Because a hexagon has 6 sides. So that would be 60. If I double 60, I get 120. If I triple 60, I get 180, right? If I multiply 60 by 4, I get 240, and so on. Okay, there's a reason why I'm stopping. Just hold on. All right, octagon, same thing, 360 divided by 8. And when I do that, I get 45. If I double 45, I get 90. If I triple 45, I get 135. And now I hope you understand why I'm stopping, because none of these numbers are 135. None of these numbers are 135. Now, the reason why I stopped was after 216, the numbers are getting bigger, but I wanted 135. I'm not going to be getting 135 up here, okay? Same thing here. I needed 135, which is somewhere in here, but I skipped all the way from 120 to 180. If I kept going, multiplying by 5 and multiplying by 6, it's not going to give me 135, but look at this, boom, 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 there it is. Okay, so the answer is choice 4. Okay, so for number 16, this is completing the square. So when we complete the square, what we like to do is we like to get our x values together, like group together, and then we're going to group our y values together. And then the last thing that we're going to do is we're going to move any constant that doesn't have an x or a y, and we're going to move it to the other side. Okay, and the way that I'm going to do that is I'm going to add 5 and then add 5 to 0 like that, so that will cancel that out. Okay, so let's get a move on. So I'm going to start by grouping the x's. So I'm going to have x squared minus 2x, and then I like to write a box. Some teachers teach it where it's just they underline and leave a space, whatever you prefer. Then I have a plus y squared, so plus y squared with a plus 4y. And then again, I'm going to do a box. And then remember, I move that 5 over, so now that's a positive 5. Okay, so if you didn't learn this box method, I'll explain. I know you probably learned it just a different way. So I have 2 boxes on the left. So if I have 2 boxes on the left, I want 2 boxes on the right. We want to even those boxes out. 2 on the left, 2 on the right. Okay. So now, if you remember, we're going to take half of that number. So I'm just put a little 1/2 there. So I'm going to take half of that number, and what I'm going to do is I'm going to, instead of writing x squared, I'm going to write x, and half of that -2 is -1. And then I put a little square there. Then what I do is I take that -1, okay, and what I'm going to do is I'm going to square that -1, square it. So you can do -1 in parentheses in the calculator, squared. And when you do that, you will get +1. Now, if I put a +1 in that first box here, I'm going to put a plus in that first box here. All right, so I'm going to repeat this whole process for the y guys. So I'm going to start by taking half of just the regular y term, just like I took half of the regular x term. So that is going to give me y plus 2, because half of 4 is 2. And again, I square. Then I'm going to take this and I am going to square that positive 2. So 2 squared, that gives me positive 4. And then what I do on the left, I do on the right. Okay? All right. So then what I'm left with is x minus 1. That quantity is squared. This plus sign right here, I'm going to be bringing that down, plus. And then I have y plus 2. That quantity squared equals, and then I add up 5 plus 1 plus 4, which is 10. So I'm going to go beyond what the question's asking just to show you what could happen in case we had a different type of question. So what that does then from here, let me just pick a different color. These numbers here give us the center of my circle. And the center is the opposite sign. So that's a -1, so that will become a +1. And that's a +2, so that will become a -2. That's the center. If we want the radius, which is what this question is asking for, we take this number right here and we take the square root of that. And that is your answer. Okay, so when you want the center, you take the opposite sign. And then if we want the radius, always take the square root of this number that we have here. Okay, this one will be a quick explanation. When we're dilating a line by a scale factor of, in this case, of 2, centered at the origin, super easy. All you do is you always take the y-intercept and you just double it. And then your slope, which is your 4, will always stay the same. And there's your answer. Okay, so scale factor of 2, you always double the y-intercept. Don't touch the slope. Okay, so I know that perpendicular lines have negative reciprocal slopes. So what I'm going to do is I'm going to find the slope of RH. And you can see up here, I just did the slope. So I did y2 minus y1 over x2 minus x1 right here. Put this in my calculator and just have it reduced. Okay, so this is the slope of RH, but we need a line perpendicular to RH. So when we're doing a line that's perpendicular, as I said before, we are going to do negative reciprocal slope, which means flip and negate. Okay, so since this is already negative, when we negate a negative, it becomes a positive. And flipping just means take the denominator, put it up to the numerator, and the numerator and down to the denominator. So there is the slope of that perpendicular line. So now if we go up and we look, we know that the answer, well, actually, don't we really know that the answer has to be this one? Because the slope has to be 3/4, which this is. That's -3/4. That's not it. And neither of these are 3/4. So there's your answer. Okay, so for number 19, I'm going to tell you that the answer is choice 2. And what I want you to do is, can you please remind me when I see you next? I want to go over this one in person, okay, because I don't know how you learned it, if you remember how to do it, but I have a pretty cool way on how to do it, and it'll be easier if I explain it in person. So let's just skip this one for right now. Okay, so based on what I just underlined here, I know I have a rectangle, and I know the formula for the area of a rectangle, because this says area right here, is base times height, or maybe you learned it as length times width. Okay, same thing. So here, I'll write that down, length times width. So then I know that my length and my width are 3 and 4. So I know that the area is 12, right? Okay, now they're telling me the rectangle is dilated by a scale factor of 1.8. Okay, we have to be a little bit careful here because area, like if this width is 3, I'm just going to make this up. Maybe that's 3 centimeters, right? And maybe this is 4 centimeters. So this is really centimeters here and centimeters here. And what's centimeters times centimeters? Hopefully you learned when you're doing area, that would be centimeters squared. So when we're trying to use a scale factor of 1.8 on an area, it's not just 12 times 1.8, it's 12 times 1.8 times 1.8. Or another way to look at it is 12 times 1.8, that quantity squared, which is 38.88. And then when we round that, that will round that 8 up to a 9, which is choice 4. Now let me just go back. So the reason why it's this, when we do a scale factor, we multiply the length by the scale factor and the width by the scale factor. So if this length is 3, that would be 3 times 1.8 and 4 times 1.8. So do you see I'm multiplying by 1.8 twice? That's why I have that there, okay? Okay, so you have expressed the questions like this are difficult. And I think you would be, right up there with about 99.9% of students who would agree with you. Okay, but all my goal is really to try to just get you more points. Okay, so if you can't get from A to Z, beginning to end, it's totally fine, completely understandable. Like I said, 99% of the population would agree with you. So we may not get to the end of this, but I wanted to show you there are some things that you can do that will at least give you a point here or there. Okay, so let's start with this. So EH is equal to OP. So I'm sure you learned that when that happens, you like to mark your diagram. So EH and OP. Okay, now let's look at the next thing. So the next thing they gave me is that EP is equal to OH. Now, EP is this whole thing with like T somewhere, in between. And then we also have HO is this whole thing with Y somewhere in between. So when I have a letter in between like that, it's kind of annoying, but so I do like a little curly bracket thing like that. There's EP and here's OH. All right. So what I want you to try to envision is I want you to look at HEPO, or I guess we really could have done HOPE because it spells hope. All right. That is a four-sided figure, right? Look, this side is equal to this side, and this side is equal to that side. What kind of a four-sided figure has opposite sides that are equal? And hopefully you are saying, oh, Miss Carter, it's a parallelogram. So you can say hope is and I like to do this symbol for parallelogram because honestly, I'm just too lazy to write it all out. You could, on the regions, I probably write it all out, to be honest with you. And I don't know how picky your teacher was for your reason. You could write definition of a parallelogram. If your teacher said, can't do that, then you would just say a quadrilateral, I'm going to abbreviate that, with opposite sides equal is a parallelogram. Okay, and again, I'm abbreviating just to kind of, save time. So guess what? We just got 1 point. All right. So even if you don't know where statement number 2 is going to take us, that's totally okay. Name of the game, we need to just get some points. All right. So let's look at the next thing. So they tell us that EJ is equal to OG. All right. I don't love this one. I'm just going to be honest with you. But so I'm going to use a square bracket just so EJ is equal to OG. Boom, boom. I'm going to ignore that for right now. That's something, you know what? I'm going to make a command decision at this moment. When I see you next time, I can go over how we might be able to prove something from that. But I'd really rather ask you in person if you know what we could prove. And if you don't, it's totally fine. But all right, but this is here. This is really good stuff. So TG, so let me get my pointer going. TG is perpendicular to diagonal EO. TG is perpendicular to this long line. And then YJ is also perpendicular to this long line. What do perpendicular lines make? And hopefully you're saying, oh, they make right angles. So what I'm going to say is then this angle right here, so TGE, that's a right angle. And so is YJO. Now I'm picking this angle and not this one out here because this one's inside a triangle and this one isn't. But if you said that this is a right angle, it is true, but this one's going to be more helpful to us. So I'm going to say that this angle right here and this angle right here are right angles. Why? Because definition of perpendicular lines. So here we go. And look at that. Guess what? We just got another point. So now we're up to 2 points. That's huge. Okay. Now, hopefully you learned that obviously, if this is 90 degrees and this one's 90 degrees and they equal each other, right? I mean, that makes sense, but you have to state it in a proof. You can't just assume that whoever's grading your paper knows that you know that. So these two steps are like a package deal. So then you always just want to go one extra step and say that that one angle is equal to the other angle. Okay? And why? Really easy. All right angles are equal. Meaning, if this guy is 90 and this guy is 90, then obviously these guys have to be equal to each other. And look at what we just got. We got 1, 2, 3 points. 3 points on a 6-point question. That's half. Woohoo, go us. Okay. All right. So the rest of this, we're just going to stop right now. This video is long enough and we'll go over the rest of it when I see you next. Okay.